Hi, this is Mrs. Vrobel. This is Chapter 11, Stoichiometry Part 2. So in the previous slide or video, we talked about how to use stoichiometry in the stepwise process converting between reactants and products. Now we're going to talk about limiting reactants and percent yield. And this is like one of my favorite parts because I get to talk about sundaes. So if you look in the picture here, we have a hot fudge sundae, and I'm sure you've made one of these at home. So notice that there's 2 scoops of ice cream, 1 cherry, 50 mils of chocolate syrup, and that equals 1 sundae. So this is the formula or the recipe that we need in order to make 1 sundae. Now, the problem is, how many sundaes can we make? Now notice that there's 2, 4, 6, 8 scoops of ice cream. And we have 2, 4, 6 cherries. Then we have 100 mils of chocolate. So my question to you is, how many sundaes can we make? And if you want to go back to the previous slide, you can check and see. Notice, because we have a limiting factor, or what we call a limiting reagent, chocolate syrup, there's only 100 mils of it. And notice that in order to have a correct sundae, we need to have 50 mils each. So we have plenty of extra cherries, plenty of extra ice cream, but that doesn't matter. We need to have that chocolate syrup in order to have 2 sundaes. So the chocolate syrup is the limiting factor or the limiting reagent. Now, we can apply this to chemical formulas. So here we have 3 hydrogen reacting with nitrogen to give us ammonia. So we actually have a certain amount of each. And what we have to do is we have to figure out the moles of the reactant. And after we figure out the moles of reactant, we can convert that to moles of product. Once we do that, we can figure out the limiting reactant that tells us how much product we can get. So here I have 2 calculations just to show you, and if you look at each calculation here, notice that we have 6.7 moles of hydrogen. We have to use the coefficients to give us a mole ratio, and here we look at 4.47 moles of NaCl. I'm sorry, that should be moles of ammonia. That was from a previous slide. Here we have 3.2 moles of nitrogen, and we're using the coefficients to give us a mole ratio, and we get 6.40 moles of ammonia. So notice that the smaller amount is actually coming from the hydrogen. So don't be fooled. If you see one has a greater mole than the other, do not assume that that is excess, okay? In this situation, it was not. So hydrogen is the limiting reagent because it only produces this much ammonia. The excess is nitrogen, and it produces more ammonia. Okay, here we have a jar of hydrogen and nitrogen. So notice the blue spheres, the dark blue spheres are nitrogen, the light ones are hydrogen. So before the reaction, if we were to divvy up all of the material that we needed to produce the ammonia, notice that we have a grouping of it. So we have, 1, 2, 3, 4, 5. We have 5 groupings, and they can essentially create 2 ammonia molecules per grouping. So looking at this reaction again, notice that we have a different grouping here, and we only have 3 sets of reactants. We have an excess of nitrogen because hydrogen is the limiting reagent. It actually restricts the amount of product that we have. So we could have excess nitrogen and it doesn't matter. It's not going to give us more ammonia. Okay, so for steps for determining limiting reactant, the first thing is you want to determine the mass of one reactant, and you're going to use stoichiometry for that. you're going to compare the mass of the other reactant to determine which one produces the smaller amount. Once you've done that, that'll tell you what the limiting reactant will be. And these are just theoretical amounts. We're looking at which one theoretically will give us the smaller product. And you can then determine the maximum yield. So the limiting reactant is going to tell you how much product could you get theoretically if you were able to convert it all to product. This leads us to one more topic, which is percent yield. Percent yield you've already done in the lab, and it's really, really easy to do. Percent yield is you take the actual yield. So how much did you weigh out in the lab divided by the maximum. The maximum is what you calculate theoretically, and then you want to multiply it by 100. So for instance, we have hydrogen plus oxygen to give us water. We have 5 grams of hydrogen, 42 grams of oxygen. We're going to look for the limiting reactant and then determine the maximum yield. So the limiting reactant will give you the maximum yield, and the actual is what you're going to weigh out in the lab. So the question is, if you have 38.6 grams of water forming, what is the percent yield? Do you want to try this on your own? I think you can do it. We will definitely talk about this in class.